Hello students, today in your geometry class we're going to be working on parallelograms. So at the end of this lesson you should be able to identify parts of a parallelogram. So let's go over a few definitions before we begin. Now Theorem 6.1 states that opposite sides of a parallelogram are congruent. Now what this really is saying, which I think should be fairly obvious, is that if you have a parallelogram like so, that means that these opposite sides are going to be congruent to one another. So these will be congruent to each other, and these will be congruent to one another. And that's what Theorem 6.1 states. Theorem 6.2 states that opposite angles of a parallelogram are congruent. So in this one, they're saying that this angle is congruent to this angle, opposite angles, and this angle, which we're going to distinguish with the two arcs, or in this case ugly arcs, these two are congruent to one another. Now, Theorem 6.3 states the diagonals of a parallelogram bisect each other. So to illustrate that, we're going to draw a new parallelogram like so, and we're going to draw two diagonals really quick. So these are the diagonals of a parallelogram. What it's stating here is that the diagonals bisect each other. So this will be congruent to this, and this will be congruent to this line segment. Last theorem is Theorem 6.4. It states that if three or more parallel lines cut off congruent segments on one transversal, then they cut off the congruent segments on every transversal. So line segment BD is congruent to line segment DF. So BD is congruent to DF. So here they're showing you that here we have three parallel lines, and they cut these two transversals. Now they're saying because line segment AC is congruent to line segment CE, then because of that, then that must mean that line segment BD is congruent to DF. Now notice these two line segments we're saying are the same, but we're not saying that they're congruent to AC and CE. So now let's try a couple problems. In example 1, there's one other theorem that I don't believe they covered, which is that in a parallelogram, the consecutive angles are supplementary. Therefore, if we take 56 degrees and add that to x, that's equal to 180. So hopefully by now you should know how to solve for x. So we're going to subtract 56 to both sides. We get x is equal to 124, and that's how we solve for x. Example 2, this is based off of the angles, and remember opposite angles in a parallelogram are congruent to one another. So we have 3a plus 50 equals 104. We're going to subtract 50 to both sides. We get 3a is equal to 54. And we're going to divide 3 by both sides. A is equal to 18. So A equals 18. Last example states that PT, and let's draw a picture real quick to make this easier. Line segment PT is 2x. So that's 2x right here. Line TR is y plus 4. Xt is x plus 2. And ts is y. Now remember, because we have a parallelogram, we know that the diagonals bisect each other. That means that x plus 2 equals y. And we also know y plus 4 equals 2x. now that we have these two equations, to solve for y, we're going to solve them as if they were a system of equations. Therefore, because in this equation we know that y is equal to x plus 2, we can substitute that into the second equation. So for this one, we have y, but we don't want to use y, so that's x plus 2 because we got it from the equation on the left. Add 4 equals 2x. So we're going to subtract x to both sides. We have 2 plus 4 equals x, therefore x equals 6. So now we've solved for x. Now we have to solve for y. Now we know that y is equal to x plus 2. Therefore we have 6 plus 2 equals y, and y equals 8. That's pretty much it. Now it's your turn. Try these 3 problems and post your answers to Edmodo. That's all for now. See you guys next time.